In the second part of section 2.2, we will talk about lines. First off, the slope of a line, denoted by the letter m, is the ratio of the rise to the run. That is, slope equals to rise over run. Rise is the vertical change between any 2 points, and the run is a horizontal change between any 2 points. The vertical change can be given by y2 minus y1, and the horizontal change can be given by x2 minus x1. Change in y over change in x, that is the definition of our slope. So let's take these 2 points, negative 5, 2, and negative 1, 0. We have a line that passes through these 2 points. We want to find the slope of the line. We will do this 2 different ways. The first way is by using the graph and counting. So we want to find the change between the y's, y2 minus y1. So it doesn't matter which point we start with. Let's start with this point on top, and we look at the change in y's. So we're going from y equals 2 to y equals 0, so the change in y is 2 units, but since we're going down in the negative direction, that change will be negative. Now let's look at the change in the x's, x2 minus x1. So for the x's, we are going 1, 2, 3, 4 units to the right. In other words, we're going from negative 5 to negative 1. That's 1, 2, 3, 4 units. And because we are going in the positive direction, that's 4. So our slope is our rise, which is negative 2, divided by our run, which is positive 4. And if you reduce this, this will give you negative 1/2. Here's what the slope means. It means that on any point in this line, if we go down 1 unit and across 2 units, we will get to another point on the line. Let's test that. So from negative 5, 2, we will go down 1 unit and across 2 units, and we get another point. Down 1 across 2, we get another point. Down 1 across 2, we get another point. So these 4 points, we can keep doing this. We can go down 1 across 2, we will get another point. So this is like a set of directions or a formula to get from one point to the next. To go down 1 across 2, get down 1 across 2. We can also find the slope using another method, using the formula. For that, we have to label one point as x1, y1. It doesn't matter which one. So let's take the lower point, label that as x1, y1. So first x, first y. And the second point will now become x2, y2. Second x, second y. So by our slope formula, we will take y2 minus y1, divide this by x2 minus x1. Once you have the points labeled, we just have to go in and see what these points are. So y2 is 2. So we have 2 minus y1, which is 0, divided by x2, which is negative 5, minus x1, which is negative 1. I always put the second point in parentheses, and the reason for that is because sometimes we get this double negative, and the parentheses will help us with that. So 2 minus 0 is 2. When you have two negatives back to back, that does become a positive. So these two negatives, they will become a positive 1, and negative 5 plus 1, that's negative 4. If you reduce 2 over negative 4, this becomes, the negative moves to the middle because you have a positive divided by negative, and 2/4 is 1/2, so our slope is negative 1/2. Same thing we got using the graphical method. The graphical method is impractical because we don't want to have to draw a graph each time. So in this case, when we have our x1, y1 and our x2, y2, we will just apply the formula. We have our y2, which is negative 6, minus, and the second point I always put in parentheses, our y1, which is 2, divided by our x2, which is 3, minus parentheses, our x1, which is negative 7. Always have a parentheses around the second point. Negative 6 minus 2, if you have two negatives, they make a bigger negative, so that's a negative 8. So two negatives, when you add or subtract, they give you a bigger negative. On the denominator, we have two negatives back to back. So when that happens, when we have two negatives back to back, that does give us a positive. And 3 plus 7 is 10, so we get negative 8 over 10. Let's divide these each by 2. This gives us a negative 4/5. So our slope is negative 4/5. This one, let's do in class. So I want you to label the first point as x1, y1, second point as x2, y2, and in class we will find the slope. Let's talk about the slopes of vertical and horizontal lines. So let's find the slope of the line that passes through 3, 2 and -1, 2. So this is your x1, y1, x2, y2. By the formula, we have y2 minus y1. So we have 2 minus 2 divided by x2 minus x1. It's -1 minus 3. So 2 minus 2 is 0, and -1 minus 3 is -4. 0 divided by anything is always going to be 0. There's an exception if you divide by 0 as well, but we'll talk about that later. So 0 divided by -4 is going to be 0. So this has a slope of 0. If we graph these points real quick, so we have 3, 2 and -1, 2, we get a vertical line. And what's special about vertical lines is that every single y value will be the same. The x's are changing, but the y's will always be at 2. So when we do our x2, or when we do our y2 minus y1, we'll always get a 0 on the numerator. So all horizontal lines have a slope equal to 0. Every single line that's horizontal will have a 0 slope. Let's take a look at vertical lines. So in this case, that's our x1, y1, x2, y2. So our slope m, it's 3 minus -1 divided by 4 minus 4. So 3 minus -1, that becomes 4. 4 minus 4 is 0. Now in this case, if you divide by 0, this will give us an undefined answer. And the way I remember which one's which is when the 0 is under the fraction. Notice that under and undefined, they have the same 4 starting letters. So when the 0 is under the fraction, the answer is undefined. So all vertical lines have an undefined slope. This line, if you were to plot the points, we have 4, -1, and you have 4, 3. So if this is a vertical line, and the reason it's vertical is because the x's are constant at 4. So when we do our x2 minus x1 on the denominator, we'll always get a 0, no matter which points we pick. So all horizontal lines have a 0 slope. All vertical lines have an undefined slope. Now let's use the slope in order to graph lines. An equation of a line with slope m and y-intercept b is y equals mx plus b. So the coefficient of the x, that's your m, that is always going to be your slope. And remember, if you set the x value equal to 0, then this disappears, and then b will be your y-intercept. So x equals 0 and y equals b, that's always going to be the y-intercept. So to find the slope and the y-intercept of a line, we always solve for y. Anytime the directions are find the slope of a line, graph the line, find the y-intercept, we can always solve for y, and then this will give you the slope, and the point 0, -4, this will be the y-intercept. And we can also use this to graph the line. So in this case, we need a starting point. So our starting point is our y-intercept, which is 0, -4. And our slope is 3 over 2, which means we are going to go up 1, 2, 3, and across 2. That's our second point. And we can keep doing this forever. We can go up 1, 2, and 3. We can go across 2. We get another point. So if we connect these points, we will get a nice straight line. Recall with lines, you have to have arrows on each end to indicate the line continues infinitely in each direction. So to graph any line, first get the y by itself, start with the y-intercept, and use the slope to get more points. Okay, so our slope m is 3/2, and our y-intercept is 0, -4. Let's take a look at the next one. Find the slope and y-intercept of the line, and then graph using the slope and y-intercept. So the y is by itself, which is great. This tells you that the first coefficient of x, that's our slope. And since we don't have a denominator, I'll write this as -3 over 1. Notice we don't have a y-intercept. So in that case, our y-intercept will be 0. And remember, to get the y-intercept, we set x equal to 0. So our y-intercept will be 0, 0. So to graph the line, we start at 0, 0. And our slope is -3/1, so we're going to go down 3, 1, 2, 3, and go over 1. Once again, we can go down 3 and go over 1. And if we connect these points, we will get our line. Has a y-intercept of 0, and slope is -3/1. Now, when we have this kind of a case where the y is not by itself, then we have to go one extra step, and we have to solve for y. So let's go ahead and do that. In order to solve for y, we have to first move the -4x. So we are going to add 4x to each side. To start off by solving for y, we move the -4x to the right by adding it. So this gives you -3y equals to 4x minus 9. Now the y is being multiplied by -3. So the inverse of multiplication is division. So instead of multiplying by -3, we are going to divide everything by -3. So the -3 divided by -3 is 1. That's what we want. We want the y by itself. The negative moves to the middle, so this gives us a -4/3x. Negative divided by negative is positive, so that gives you a +3. So in this case, our slope m, it's the coefficient of x, that's -4/3, and our y-intercept b is the point 0, 3. X is 0, y is 3. So we start with the y-intercept, start at 0, 3. Our slope is -4/3, so we're going to go down 1, 2, 3, 4. Go down 1, 2, 3, 4. That's our rise of -4, and the run is +3. So that's our second point. We can connect the 2 points to make a line, and we're done. Now notice that anytime the slope is negative, going left to right, the line will go downwards. And if the slope is positive, like here, the slope is positive going left to right, the line will go up, the line will rise. And here, the slope is negative, the line will fall. So, slope-intercept form, what is needed? Actually, this one we'll do in the next lesson. So let me stop here, and we'll continue this in